Hey, so this is some stuff that wasn't covered in some of the videos, and hopefully this can help you out on your retake or on your SOL. Okay, so here we go. We're going to look at some statistics problems, and so hopefully this can help you on the SOL. So here we go. This is a problem where it involves box and whisker plots, and sometimes the calculator can help you with a little bit of this, but I'm going to try to do the best I can to explain what a box and whisker plot is. All right. Box and whisker plot is basically a number line that has some sort of data being presented, and it's showing everything that's within a data set. And so what you got here is you got a whisker on the left side and a whisker on the right side with a box in the middle. Okay, so here we go. The end here is considered what's called the lower extreme. So we have three lower extremes. So we have this one here, this one, and this one. The first part of the box is called the lower quartile. So the lower quartile is here and here on these boxes. The line inside the box is called the median, and then on the end of the box is called the upper quartile, and then on the end is called the upper extreme. And those are the five pieces that make the box and whisker plot together. Okay. Now, a couple things you're able to calculate using a box and whisker plot. One, you can calculate the range. The range is from end to end. So what you would do for agriculture is you would take this guy here, looks like about 80 minus about 5 to find your range. And you would do the same thing. You would take industry, which would be 60 minus about 10, and then about 45 minus about 10. Okay. You can also find what's called the interquartile range, and what that is basically the size of the box from end to end. Alright, so here would be about 35 minus 15. Here would be about 50 minus 35, and then about 35 minus 25. Okay, so those are the things that you need to look at when you do a box and whisker plot. Now, in this question here is you got these box and whisker plots summarize the percent of the workforce employed in agriculture, industry, and service jobs in 20 towns. Which statement is not true? Industry has the greatest mean value. Well, let's look at this. The mean value, again, is the line inside the box. So, agriculture, there's the mean there, it looks about 20. Industry, the median looks like about 45, and the median for service is about 30 to 35. So it looks like industry does have the greatest median value. Okay, so it looks like that is true. Service has the range with the least value. Again, you're taking your end to end to find the range, and we can actually do this in the calculator. So you would take agriculture, do 80 minus about 5, you get 75. Industry would be about 60 minus 10, so that's industry, about 50. And then service looks about to be 45 minus 10, so 45 minus 10. And so indeed, service does have the least range value. Okay. Agriculture has the range with the greatest value. Well, let's look at that. This was agriculture, this was industry, this was service. Agriculture had a range of 75, and it is the greatest value. So those last two are true, and we're looking for the statement that is not true. So now we're down to D. Industry has the interquartile range with the least value. Okay, well, we're going to clear here, and let's look at it. To calculate interquartile range, you take the box from end to end. So you go 35 minus 15, and that's agriculture. That's 20. Industry looks about 50 minus 35, so 50 minus about 35. And then service looks about 35 minus 25, so 35 minus 25. Okay, industry has the interquartile range with the least value. Well, industry had a interquartile range of about 15, but the smallest value is service. So letter D is definitely not true, and so this would be our answer choice, letter D. Okay, box and whisker plots. Okay. All right. Another problem that uses a similar idea. Do I want to do that one? I don't think I don't. That one's a little bit tougher to think about. We'll do something simpler. Okay. Other things we have to think about is what's called standard deviation and mean. Okay. I'm going to try to do the best I can here without a pen here to write on the screen. But we'll try to do the best I can. Maybe I can get. We'll try to do the best I can. All right. Standard deviation and mean are the two things that you can pull up in your calculator using one variable statistics. That's found under Stat Calc one variable statistics. Okay. So a way to do that, if I had some data in here, let's say for example we had some data in the L1, and you can only pull data from L1. Let's say that these are my values here. Let's do 4 and 5. Let's say this is my data in L1, and I want to figure out what the standard deviation and mean are. I'm going to go over the one variable statistics because that's all the data I have in L1. Okay, so I'm going to go down to calculate. Your calculator, you'll just have to hit enter probably. Okay, newer calculators, you have to go down to calculate. Okay, there's a lot of information here, but the only information that you really need is one, the mean, which is this one right here. So our mean is 2.5. Our standard deviation is this symbol right here. It looks like a whistle. Okay, it looks like a whistle. Our standard deviation, we would say 1.71. Okay, we're going to round up from that 7 there to 771. Okay, and then other things you can find in here are the box and whisker plots information. Okay, here is your lower extreme. Q1 is called your lower quartile. Med is your median. Q3 is the upper quartile, and the max is called the upper extreme. So there's your information there for any box and whisker plot. Now, some problems are going to ask you about standard deviation. Some problems are going to maybe ask you about the mean. This is something we can find using one variable statistics. Okay. All right. Now, some things that we can also do in problems that involve the mean and standard deviation is what's called a number line. Okay. And so what we're going to do is, I'm going to see if I can pull this up. What we're going to do is we're going to use oh, I don't have this. Oh, maybe you can do it on Paint. Let's just do it on Paint. Alright. Something you can do is that you can actually pop up a number line, and the number line can actually help you figure out some answers to problems that involve mean and standard deviation. Okay, and so what I'm going to do here is I'm going to see what I can pull up here. Let's see if I can add a source here to my screen capture. Oh, yep. Oh, there we go. There it is. Okay. Alright, so right now I'm going to temporarily fill in this box, and I'm going to use this box here to do the number line idea. Okay. What you're going to do is you're going to make a number line. Whenever time you have mean and standard deviation, you can do this idea. In the middle is your mean. So in this problem here, you have week 1 with a mean of 35 hours. Okay, then in standard deviation of 1.5 hours. What you're going to do is you're going to make 1, 2, 3 tick marks to the right, 1, 2, and 3 tick marks to the left. Okay, and all you do with standard deviation is you add to the right of it, and then subtract to the left. So you're going to take 35 hours, and you're going to add 1.5 hours. So right here, this would be 36.5. Okay, I'm not very good at typing here or doing this at the same time. Okay, then you add another 1.5 hours. So now you would be at 38. Then you add another one, 39.5. Okay. Then you do some subtraction to the left of it. Okay, so you're going to subtract 1.5, so you get 33.5 here. And subtract some more, you get 32. And you get finally 30.5. Okay. You only go this far, and this should be your number line. Okay. So what I want you to do is, if you want to take a little practice of this, and you can just pause the video right here, is draw your number line and make what would week 2 look like. Okay, week 2. Your middle value, mean, is going to be 40. Okay, you do 1, 2. This is not perfect, but you probably hopefully get the idea. 1, 2, 3 to the left, 1, 2, 3 to the right. Okay. And so what's the rest of the number line going to look like? So pause the video right now and fill in this part of the number line for week 2. Alright, so to put this one together, you have a standard deviation of 2 hours. So all you're going to do is add 2 to the right. So this is 42, this is 44, and this is 46. You're going to subtract 2. This is 38. This is 36, and this is 34. Okay? Alright, so what you're asked to do here is you're asked to calculate the following statistics. You have week 1 and week 2. Now the managers concluded that there's more variation in the number of hours worked for week 2 than for week 1. The manager's conclusion was A, valid, because the mean for week 2 was greater than the mean for week 1. That necessarily doesn't have to do anything with this data set. When you're given a mean, that means you don't know what the data represented there. There could be a spread out mean, or it could be a smaller mean. Okay? And it could just be within like a certain range. Alright? Valid because the standard deviation for week 2 was greater than the standard deviation for week 1. This actually would make sense because standard deviation, what it does is it spreads out the data. Okay, so if you look at the data set here, we're going from 30.5 to 39.5, but we have a spread of 1.5 each way. Okay, this one's going from 34 to 46, and it has a spread of data that's going up by 2 as we go across, which is your standard deviations telling us that there's more data within a certain value and it's more spread out, versus this data set is not as spread out due to the standard deviation. Okay, when the smaller the deviation, that means the smaller the set of numbers that you have within your data set. The higher means that it's more spread out. Okay, and so there's more variation in week 2 because the standard deviation is actually spread out. Okay, more consistently. And so we would say, using our number lines, that the answer would be B. Okay. Alright. Now let's see. We can get rid of Windows Paint right back to the calculator. We'll go back to it if we need it. Okay. Alright, that's it on that one. I want to try to find the problem that I was thinking of with for statistics here that's actually really good. Alright, here we go. This is a good problem here. Alright, each of these data sets has a mean of 20. Okay, order the sets from the greatest standard deviation to the least standard deviation. Okay, so what you're going to do is you're going to do each set into L1. Okay, so you can go to Stat Edit, and all you're going to do is you're going to put in this data set for set 1 and find the standard deviation. Okay, so I'm going to go up to L1, highlight it, clear it. Okay, now I'm going to input the data. Okay, so here we go. So we're going to type in 18, type in 19, 20, 21, and 22. Okay, and now we'll go to Stat Calc, and we're going to hit Enter for one variable stats. We go down to calculate. You probably will just have to hit enter. Okay, so there's our mean of 20. Yes, that's correct. Now I just need to figure out standard deviation. Again, standard deviation is the whistle symbol right here. So we would guess that our standard deviation for this problem is 1.41. Okay, so for set 1, it's 1.41. We would write that down, so 1.41 is set 1. Okay, all right. Your goal is now to do the rest of the problem. Okay, all right, the rest of the problem. To figure out what is the standard deviation for set 2, standard deviations for set 3, and then come up with your answer from greatest to least. Okay, so pause the video right now. Do the last 2 sets by going into Stat Edit and then Stat Calc 1 to see what your standard deviation is. Alright, so now after you have done this problem using your calculator, okay, you will find that the set 2 has a standard deviation at about 0. Set 3 has a standard deviation at about 3. So our answer to this problem would be set 3 would go first as the greatest, set 1 would be the next one, and then set 2 will be the least. So our answer should be 3, 1, 2. Alright, we have another box and whisker plot here. Okay, another box and whisker plot. Okay, try to zoom out just a little bit more. Hopefully you can read that. If not, it's okay. I'll read it right now. A study was conducted to determine the number of cars that pass through 2 intersections each day for 20 days. The results are summarized in these box and whisker plots. Here's your box and whisker plots for intersection 1 and 2. Which statement is best supported by these data? Okay. The range of the data for intersection 2 is twice the range for intersection 1. Again, range is from the largest value and the lowest value. You subtract it to find the range. Okay, so let's look at the range. The range is 650 minus 250, and we can calculate that. It's 400. Intersection 1 is 550 and 350. So that's 350. So we're going to do minus 350. 200. So that is twice the range. Okay, so this answer would definitely be A, it looks like. Okay. We'll look at the other ones here. Lower quartile for intersection 1 is greater than the lower quartile for intersection 2. Well, here's lower quartile 1 right here at the beginning of the box. There's the lower quartile. This looks like about 375, and this one looks about 400. Intersection 2 has the greater lower quartile, so letter B is definitely not correct. Okay. The interquartile range for intersection 1 is the same as the interquartile range for intersection 2. Okay, so we can calculate that. Say 550 minus 375 here. So remember that we got to look for the same. That's 125. Okay, remember interquartile range is the length of the box. Okay, 550 minus 400 would be intersection 2. Oops, it did not go minus 400. And that's 150. They are not the same, so that is not true. The total number of vehicles that pass through intersection 2 is greater than the total number of vehicles that pass through intersection 1. I'm going to explain a couple things that box and whiskers does not do. Okay, 1, we cannot determine the total number of vehicles through this information given. Okay, we don't know what the data set inquires, how much it gives us. It could go from a huge range of numbers to a smaller range of numbers. We don't know the actual total number of vehicles that pass through each intersection. Okay, unless we have an actual data set that correspond with intersection 1 and 2, we could not figure out the total number of vehicles. Also, you cannot figure out what the mean is given a box and whisker plot, and you cannot figure out what the standard deviation is. The only way we can do that is if we actually have the actual data. Okay, we have to have the actual data. This does not give us the actual data of what it is. It's just the results from the data. It's just the information summarized. Okay, notice that it says the results are summarized. Okay, a box and whisker plot summarizes the data the data set. Okay, So it's definitely not letter D because we cannot figure out the total number of vehicles using this information. So our answer is going to be conclusion of A. The range of the data set of intersection 2 is twice the range for the intersection data for the intersection 1. Okay. I want to find one here that does. Here we go. All right. The data set has a mean of 720 and a standard deviation of 6, which is the closest to the z-score for an element of this data set with a value of 709. Okay, so we're going to go back to my nice little drawing here. Okay, we're going to see if I can get that guy to pop up. There he is. Okay, so what we're going to do is we're going to erase this guy that we have here. Oh, you know what? Let's just scroll down. Okay, the z-score formula is represented as this, and it's on your formula sheet. Z equals an element in the data set, x, minus the mean, and the mean symbol looks like this. Okay, it looks like a U or a little M or some sort. Okay, but either way, this symbol represents the mean. Okay, all divided by the whistle, which is your standard deviation. Okay, that's a poor whistle. I apologize, but that's okay. All right, so what you got here is a data set has a mean of 720. Okay, the U symbol or the M, it looks like an M. Okay, when I draw it, okay, is a mean of 720. So that symbol is equal to 720. Standard deviation of 6. That is your whistle. That was a better whistle. There we go. Alright, so the standard deviation is 6. So the whistle is 6. Z-score of an element of this data set with a value of 709. The element is x. So we know what the element is x. 709. Okay, 709. So this is our z-score formula, and all we got to do is just insert the numbers where they belong. Okay, so if we look at this problem, we're going to find what the z-score is. So I'm going to say, okay, z equals 709, because that's x, minus 720, which is your mean, all divided by 6. Now, when you go to input this into your calculator, you're going to have to put parentheses around the top. That's terrible parentheses, but whatever. Okay, so you're going to put parentheses around the top so that you subtract this before you divide it by 6. Okay, so let's look at that in our calculator. Okay, here we go. We're going to do parentheses 709 minus 720, all in parentheses, then divide by 6. We're going to press enter. Negative 1.833 repeated. If we look at our answer choices here, we have 11, 1.83, negative 11, and negative 1.83. Our answer would be D. Okay, D. Now, here's the thing. A couple of things about z-scores. Z-scores should not go above 4 or below negative 4. If you get anything, beyond 4 or negative 4, then there's something wrong in your problem. So, for example, in this problem here, we should have already eliminated A and C because those numbers are way too high to be z-scores. Your z-scores should be falling in between negative 4 and 4. Okay, so anytime you calculate a z-score, it should be between those numbers. Okay, so this is a problem that could actually pop up. Your z-score formula is on the formula sheet for your test, and so go to that if you have a problem that involves these 3 items: mean, standard deviation, and an element, or mean, standard deviation, z-score, or mean, element, and z-score. And we're going to look at one that has mean, element, and z-score right now. Okay, and it's on this test. Here it is. Okay. Statistical information for a data set is given. The mean is 18.1. The z-score for 13 is negative 1.7. Okay. This question could be a little confusing because you have three things there and you want those three things. Okay, so let's look at this problem. Okay, we're going to use our trusty z-score formula again. All right. This time we have the mean is 18.1. Okay. We have a z-score for 13 is negative 1.7. Okay, the z-score cannot be 13 because that's way too high for it to be a z-score. Okay, the z-score is actually negative 1.7. So actually we know what z is this time around. It's negative 1.7. All right. Then 13. 13 is actually your element in the data set. Okay. This time we're finding what standard deviation is. Okay, so in order for us to do that, we need to set up what this looks like. Well, here we go. Negative 1.7 equals 13 minus 18.1 all over, and we don't know what standard deviation is, so it's all over the whistle. Okay, we need to figure out what the whistle is. Now, here's something we can do. All right, we have these answer choices here: 1.7, 3, 3.4, 5.1. What we can do is say, okay, well, let's see what happens when I put 1.7 in as the whistle. Okay, so let's see what we can do here. I'm trying to figure out where's my eraser on this thing. Eraser. Hello, eraser. Where is my eraser? That's odd. Let's see if I can find my eraser on here. View? No, it's not view. Isn't there an eraser on here? Anywho, I'm not gonna figure that out right now. Okay, so what you're gonna do is you're just gonna say, okay, well, what if I just do this? I can probably do this idea. Let's try this. Okay. All right. So what if I take 1.7 in and just put it in for the whistle? Okay, what if I just do that? Okay, so if I put that in, does it equal negative 1.7? Okay, so let's calculate that. Again, you're going to need parentheses, so we're going to do 13.0 minus 18.1 divided by 1.7. If it equals negative 1.7, we're good. Nope, it equals negative 3. So this is not our answer. Okay. And that's a good thing that we can do. Okay, it's a good thing. And I just realized I need to hide the window for a second. So there's the information. Sorry. Okay, so we type this into the calculator. We get negative 3, and that's not our z-score because the z-score says is negative 1.7. Okay, it's not negative 3. It's negative 1.7. Okay, so it's not A. All right. So now we're going to go back and we're going to say, okay, well, it's not that one. All right, it's not that one. So now we're going to do, let's see, yeah. Okay, so now we're going to do, and get rid of this. Okay, so let's say now that our standard deviation is 3. So we're going to do the letter B. So now we're going to go in, okay, let's do 3 as our standard deviation. Okay, so let's put in 3.0. If this is right, if this is negative 1.7, this is our answer. Okay, again, go into our calculator. Type it in. 13.0 minus 18.1 divided by 3.0. And there it is, negative 1.7. There is our z-score. Okay, we got the exact z-score that matched in our calculator. Okay, so there it is there. There it is there. Our answer is B, and we're done. Okay, we're done with the problem. Alright, so we can actually set up the z-score. We can actually set up the z-score formula to help us figure out standard deviation. We can also use it to help us find the element. Okay, so whatever elements equal that, or what elements are greater than that, is going to help us. Okay. Alright, so I think this is it on some of these problems. When it comes down to, yep, that one's done. Okay, I think that's it. Okay. Ideas that involve these kind of problems that use statistics will be able to help you on your tests, and hopefully those little ideas can get you through the last little parts of your tests. Okay. So anyway, these are the ideas when it comes to statistics that that I didn't have time to mention before, but hopefully these little ideas can help you. Okay, so remember how to do the box and whisker. Go back through at the very beginning of the video to learn the box and whisker plots. Okay, go through the video again and look at how to use the z-score formula. So for a problem like this is a z-score formula, and there's a bunch of problems that I've seen in the past that have used the z-score formula. Be familiar with that and use that. That will be on your formula sheet, so use that formula. Okay, and so be able to use those things and see what you can do with it, and hopefully this can help you out with the last little bit of